Only was presented today. Now, if you do what happened here, again add HI here. Now, where iodine attacks? Tell me, ethyl part or isopropyl part? Tell me better. This is ethyl part. This is called isopropyl part. Ethyl part. Very good. Why? Because small group it is. Ethyl is compared to this is small group actually. So definitely the product must be CS3 CH2I plus CS3 CS3 OH. Isopropyl alcohol, ethyl iodide we get actually. You have any doubts regarding these two questions, beta? Are you having any doubts regarding these two questions?
No, sir.
Right. Now, we'll take now tertiary now. We'll take now tertiary. OCS3. Now, if you follow this rule actually, we should get this product actually. CS3, CH3, here also CS3, OH and CS3I. We may get this product actually, but this is wrong actually. According to this rule, we should get like this CS3I we should get actually. But in true, what is happening? That means when you take tertiary, only when you take tertiary, that means when you take primary, when you take secondary, no problem. But tertiary, when you take, this is according to SN2 mechanism. Tertiary is based on SN1 mechanism. That is the reason you are getting reverse product actually. Let me see this one more time. So what is happening actually? Let me see the mechanism also. CS3, okay, CH3, here also what happened? CS3, OCS3. Now here two ways I am taking actually. Now if this bond is shifted like this here, if this bond is shifted here, what we are going to get here? CS3, CH3, CH3, O minus, CS3 plus. So primary carbonium ion you are getting. Primary carbonium. Now if I take what reversely like this. CS3, again CS3, CS3, O, CS3. Now if this bond is shifted like this, reversely, what we are going to get? CS3, CS3, positive charge, plus CS3, O minus. Now this one is tertiary carbonium. Tertiary carbonium. Now, which is more stable, primary or tertiary? Which one is more stable better? Primary carbocation or tertiary carbocation?
Tertiary.
Tertiary carbocation is more stable. Now, in this case, this is more stable. So, readily what happen? I minus will attack here and H plus will attack here. So, what product we are going to get in this case when you take tertiary? What product you are going to get here? Are you getting this product? No, you are not getting this product actually. You are not at all getting this product actually. Now, what you are getting instead of this one? You are getting here what actually? Iodine here. You are getting here what happened? OH. Correct? So, what I am saying here, when you take primary, secondary, if ethers are having primary, secondary like this. So, in examination, if they given what happened like this. Here, if they given primary, secondary, here if they given primary, secondary, iodine will attacks on small group actually. Okay. But if they given what happened? Here also you observe here. Primary, primary. I attacks here like this here. And here also what happens? Just a minute better, I will. So here what you are seeing here? One is tertiary you are seeing here. You're going to see here what happened? Tertiary here, right? So definitely you have to follow what happened. Iodine will attacks on tertiary carbon. So iodine will attacks on tertiary carbon, actually. Correct? This is the thing you have to follow, actually. So after the class, what happened? Try to read this one because it is following SN1 mechanism. Whereas remaining cases, primary, secondary, they are following what? SN2 mechanism. That is the reason you are getting like this. This is SN2 mechanism. You see here, this is SN2 mechanism. So directly iodine attacking here, directly on CS3, because CS3 is less steric hindrance, no? This is less steric hindrance. So that is the reason iodine is attacking directly here. So we are going to get CS3. But in the case of tertiary, what happened? Which follow, we are following SN1 mechanism, we are following. That is the reason we are getting what happened? Iodine attacks on tertiary carbon. So read this one. And when you have phenyl group, what happened? Definitely we have to break here only. You have to break here only. We are going to get the phenol. Always we get the phenol. So we'll do some exercise on this one. Let me do some exercise here. This one is the exercise. Let me do this one. Now tell me better. I will do only 2 questions here. Only 2 questions I will do. Okay. Now this one is the primary. And this one also what happened? You just check this one, oxygen bonded carbon, primary. Now which you have to follow? Iodine attacks on which carbon? Methyl or? Methyl. Here it will attack. Because both are primary. Tertiary is not there. Here you got tertiary is there. So you have to check this one. You have to do this problem. Now third one, if you observe what happened, third one, if you observe what happened, where you have to cleave, which bond I have to cleave here? Can I cleave this bond? Is it possible? Is this bond, is this type of cleavage is possible? Yes. Just now I told you, no, we can't cleave the oxygen phenyl bond. So where you have to cleave here? So definitely we should get phenol only, no? You can't cleave. Why? Because double bond character. You will get a double bond character here. So where you have to cleave here? Carbon oxygen bond you have to. sp3 carbon you have to break actually. Okay. So whenever if a double bond carbon is bonded to oxygen, you can't break this bond actually. Right? So if they given like this, benzene is given. After that, what happened? Oxygen is given. You can't break here. You have to break after the oxygen only. You have to break after the oxygen only. What is the reason? This lone pair will make a double bond character. So only 3 problems are there. 3 you can do now. Any doubts you're having in these 3?
No, sir.
Right. Now, if you have, if you see this one, 11.12 problem, instead of HI, they take an HBr, no problem, no. Instead of HI, they take an HBr now. Now, where you have to cleave this one? Already we have completed this one. You have to cleave where here? Here. You will get iodine here, you will get hydrogen. Now, for this one, what will be the answer? Tell me better. What will be the answer you are going to get in this case?
Phenol plus.
So you have to cleave bond where here? Correct or not? Now put your hydrogen. Very simple, no? This one is already we discussed now. Tertiary carbon is given. So which mechanism we have to follow here? SN1. Here what mechanism we are following in this case? SN2 mechanism. When you are following SN2, iodine attacks on small carbon. When you follow SN1, iodine attacks on bulk carbon. And here also one more question is there. No, here is not there here. No, it is not there here. Okay, let me see some more reactions here. Electrophilic substitution reactions. They are very simple reactions. Let me see that one also today. Electrophilic substitution reactions. In the last chapter also, how chlorobenzene is undergoing electrophilic substitution reactions, we have already completed. Now, how ether will undergo? How ether will undergo, isn't it? Electrophilic substitution reactions. Now, if I take here what OR, ether I am taking, something OCS3 or anything, R I am taking here. In the place of CS3, I am taking R. Now, we are having oxygen having lone pair here, right? Now, it will delocalize here. to give what happened? A negative charge over here. Isn't it? A negative charge like this. So what we are going to get? This structure we get actually. I'm writing here like this. Double bond O, CS3, positive character. Here we are getting negative. Again, if we shift, what happened? This will come outside here. We are going to get this structure. Double bond, double bond, double bond. OCS3. Here we are getting negative character. Again, if you shift this one here, the pi bond will be shifted over here. Here negative character. Double bond. OCS3. Now, where we are getting negative character, better? On which positions you are getting negative character? On which position you are getting negative character? Which positions you are getting
para.
Ortho and para position. Now, electrophile is which charge, beta? Electrophile is which charge? Positive charge. Now, positive attacks on which position now here? Ortho and para position. That means in electrophilic substitution reactions of aromatic ethers, in that case like this, aromatic ethers, the electrophilic substitution takes place at ortho and para positions. Okay, now let me see the first one, halogenation. First one is what? Halogenation reaction. Halogenation, what we are adding here? Bromine in presence of ethanoic acid. The reagent we are using generally, what happened? Bromine and ethanoic acid. Now bromine will be electrophile. This bromine will be electrophile. Attacks where? At ortho position or at para position. Isn't it? Why this one is major? Because it has less steric hindrance. There is something we are going to have more steric hindrance. No, this has more steric hindrance. Bulk groups are adjacent. No, so some steric hindrance will be there here. That is the reason it will be minor. This will be the major. So we are going to get para bromoanisole. Otherwise, 1, 2, 3, 4. 4 bromo, isn't it? Methoxybenzene. 4 bromo methoxybenzene. This is the IUPAC name. 4 bromo methoxybenzene is the IUPAC name. Otherwise, para bromoanisole we can call. This one is ortho bromoanisole or 2 bromo methoxybenzene. So this is halogenation. In this way, we have to remember. In halogenation, the electrophile is what? Bromine. That we can take chlorine also. Halogenation means you can take chlorine or bromine you can take. Both you can take. Next, actually what happened, when you compare here, when in the 11th class what happened, halogenation will do like this. Bromine in presence of FeCl3, FeBr3 like this will take. That means Lewis acid will take it. Here we don't need to take Lewis acid. Okay, this is no need actually. Because of what? High ring activating groups are there. In this, we are having high ring activating groups are there. So that is the reason what happened, because of having ring activating groups here, isn't it? You are having what? No need actually Lewis acid. Next, Friedel-Crafts reaction. Friedel-Crafts reactions. One is called alkylation, other is called what? Acylation. Now this is alkylation. Now in this case, what happened is CS3Cl, this bond is shifted over here. Now CS3 will be get here positive charge here. Now this will be the electrophile. Okay, this will be the electrophile. Methyl is the electrophile. Attacks where again? Ortho position and para position. Again, this will be major because of what? This is having some steric hindrance is there. Correct or not? Next, this part if you observe. CS3COCl. In CS3COCl, like this. C double bond OCl. Now this bond is taken by the chlorine because chlorine is having more electronegativity. So chlorine will take bonding electrons. Now what we get here? CS3 C double bond O positive charge. Now this CS3 C double bond O act as electrophile here. Attacks on which position? Ortho position and para position. Now in this way we are going to get what? Alkylation and acylation. Both we are getting it. Now here it is called what? First number. We have to give for first number for ether. functional group it is, second number for methyl. So 2-methoxy benzene, 2-methoxy what happened? Toluene. Or what happened? 2-methoxy 2-methyl benzene. Like that also we can do. Otherwise, we can call this one toluene actually. This is what actually toluene. This part is actually called toluene actually. Right? This part is called toluene actually. Now where you are having methoxy here? Here it is. Okay, now 1, 2. So otherwise what happened? This is what? Methoxy toluene. No need to write 2 actually here. But I will do one thing actually here. Instead of writing like this, we'll do like this here. IUPAC name I'm writing. What to write here? 1-methoxy. There is 2-methyl, right? Methoxybenzene. This is the IUPAC name actually, right? 2-methyl methoxybenzene. This one will be what actually? 1, 2, 3, 4. Now IUPAC name will be what? 4-methyl. In the place of here what happened? 4-methyl methoxybenzene. This is called 4-methyl methoxybenzene. This one is a 2-methyl methoxybenzene. Now what about this one? This is called acetophenone. This part is called what actually? Acetophenone. So 2-methoxyacetophenone. This part is again called as what? Acetophenone. So 4-methoxyacetophenone. Generally acetophenone means looks like this. CH3, C double bond O, PH. Okay. Or else you can also write like this. CH3, C double bond O, benzene. This is called actually what? Acetophenone, right? Acetophenone it is. How to make benzophenone? Because these structures are very important. Make 2 times phenyl group here. Here phenyl and other there also phenyl like this. Or you can also write like this also. Benzene, C double bond O, benzene. Now this is called what? Benzophenone. Benzophenone it is. So these two are called benzophenone. These two are called acetophenone. Okay, this is called 2-methoxyacetophenone, 4-methoxyacetophenone. Like finally what happened? We'll take a nitration reaction. We'll take the nitration reaction. In nitration mixture is what? H2SO4 plus HNO. The electrophile will be NO2 plus. This will be the electrophile. You come to 11th class, we studied this one. Again, attacks on ortho position and para position. Again, because of steric hindrance, this will be the minor product, and there is no steric hindrance here, and this will be the major product. So these are the electrophilic substitution reactions of, isn't it? Anisole. Now, let me see some questions here. Some questions, let me see. In text questions, let me see. See. Now, 2-methoxy 3-methyl-pentane. 2-ethoxy 3-methyl-pentane, starting from ethanol and 3-methyl-pentane to 1. I want to get this one. 2-ethoxy 3-methyl-pentane. Let me see how to make this one. You take what happened? Pentane like this. 5 carbons I have to take. 1, 2, 3, 4, 5 carbons I have taken. Pentane. Third carbon is having methyl. Put here what? Methyl. Now give numbering also. Give numbering also. Second is having ethoxy. OC2H5. Ethoxy it is. Now put here what happened? Methyl groups. Here 1 hydrogen. Here 1 hydrogen. Here 2 hydrogens. Now you have to produce this one. You have to produce this one. How to get this one? They are asking. Now they are asking starting from ethanol and 3-methyl-pentane 2. How to get this one? So I have taken first of all what happened? 3-methyl-pentane 2. Take this one again, 5 carbons, 1, 2, 3, 4, 5 carbons, right? 5 carbons I have taken. Now in this case, second carbon is having OH, third carbon is having methyl. Okay, again put here 3 hydrogens, put here 3 hydrogens, here it is put 1 hydrogen, here put 1 hydrogen. Now how to get this structure? Now treat this one with sodium hydroxide. When you treat this one with sodium hydroxide, what happened beta? This hydrogen, this OH will be removed. So what we are going to get here? What we are going to get here? Anybody? What we get here? In this case?
3-methyl pentane 2-ol.
The case this one you get here actually sodium we get. Correct or not? Sodium we get. Right? Now, next. How to get this product actually? How to get this product? Very simple. What is the difference between these two? What is the difference between these two? This C2H5 is not there. So what I am taking here? Chlorine, isn't it? C2H5. Now NaCl is removed. Now you got this product. Now which reaction beta? This reaction? Which reaction it is? Which reaction it is? Which
Riemann-Tillman reaction.
Okay, beta. What we are discussing? 11.10. We are discussing 11.10. Write the reaction of Williamson synthesis. Williamson synthesis reaction है ना ये नहीं है? बोलो.
Yes, sir.
Williamson synthesis reaction it is. In Williamson synthesis reaction, we are preparing this one. We are preparing this one, sorry. We are preparing this one by using this one. By using this one, right? By using this one, we are preparing this one. So I have taken this one, first of all, actually, I have taken this one. And I got this one by reading with this. Correct or no? Understood this 11.10th question?
Yes, sir.
Next, 11.11, if you observe what happened. Which of the following is appropriate set reactions for the preparation of 1-methoxy, 4-nitro-benzene and Y? You want to get what product we actually get actually here? One methoxy, 4-nitrobenzene. I want this one. Which method is correct one? They are asking. Right. Let me see this one. Here, what happens actually? According to the last Williamson synthesis reaction, the alkoxide must be bulk group. Correct or not? Tell me. How many of you remember this one? The alkoxide must be bulk group. How many of you remember this one? How many of you remember this one? So this is the reason what happened. You have, before coming to the class, at least you have to read the textbook. What we have completed yesterday. Otherwise, what happened? Definitely, you will get doubts. Yes, you will get definitely doubts actually. See. The bulk group should be on alkoxide. ONA, here it is what? And CS3Br. NaBr is removed. Now what we are going to get? This product we are going to get. The alkoxide must be bulk group. Yesterday only we'll discuss this one. We have completed this one actually. Let me see. Again, I'm showing that one. देखो यहाँ पर है ना, the alkoxide must be bulk group. The alkoxide must be bulk group. Right? See, here also you are taking. The alkoxide is must be. I given some homework also. Better result are obtained if the alkyl halide is primary, isn't it? The alkyl halide must be primary. That means what? Small group. Primary means what? Small group. Then this group, alkox said this should be what? Always bulk group. Understood? Anybody having doubts in this one? Williamson synthesis reaction? Because very, very important in examination. Definitely they will ask in exam. Surely you will get a question from Williamson synthesis reaction. Are you having any doubts?
No, sir.
Williamson synthesis reaction. Yesterday, whatever the Williamson synthesis, just watch that video again one more time. Only that Williamson synthesis. So that what happened, you don't get any doubts. ये 11.24 हमने क्लास में किया है ना 11.24.
Yes, sir.
What are the limitations of Williamson synthesis reaction? Certain type of ethers, what you are found here? The tertiary is what very difficult in this case. हमने डिस्कस किया है सारी चीज. This one 11.28 hydrogen iodide with 1 propoxypropane, methoxybenzene, benzyl ethyl ether. Let me do this 11.28 here. 1 propoxypropane. One propoxypropane. It is called 1 propoxypropane. Reacting with what? HL. Now I think you can do this problem. I think no. You can do this problem. I think. Correct or not? Yes or not?
Sir.
Right. Next one. Methoxybenzene. Methoxybenzene. This one also is there with HI. Next one. Third one. Benzyl ethyl ether. Benzyl ethyl ether. Benzyl. This is part benzyl. This is benzyl. Phenyl means only benzene. Benzyl means with including one carbon. Benzyl. What is that one? Benzyl ethyl ether. Ethyl ether. Put here ethyl group. Now where we have to cleave, anywhere you can cleave no here, because symmetrical molecule, we can cleave anywhere. If we get iodine here, you will get here hydrogen. Now where you have to cleave here, beta? Here or here? First position or second position?
Second.
Very good.
Second
So what we get in all cases, what happen? We get the phenol only. Plus CH3 ion. Now here we observe here what happened. This is the bulk group. Okay, one more thing, if you observe what happened, here we have to follow one SN1 mechanism only. Let me see this one. Just a minute. Now I am doing what happened in this way. So what we get here? CH2 plus what we are going to CH3 CH2 O minus. Now H plus will be added here, so we get ethyl alcohol. Here iodine will be added here, so we get benzyl iodine. Now here one more exception you have to follow here. Now whenever we get benzyl group, This is also stable here. How this is stable? Because of resonance here. Now here it can undergo resonance. Benzyl carbocation is highly stable, correct or not? Benzyl carbocation is highly stable. Therefore, what happened? You are going to get resonance structures. Therefore, it will follow which mechanism again? SN1 mechanism. That means wherever you get a carbocation, stable carbocation. If you get a stable carbocation, follow SN1, iodine attacks on bulk group. So similarly, like tertiary carbocation and what benzyl carbocation, isn't it? In these two cases, SN1 is possible here because of stable carbocation here. So we get here actually this product actually. Okay. So this is also one exception case actually. Benzyl when we get actually. And reaction with mechanism तो हमने डिस्कस किया. ये सारी चीज फिलरक्राफ्ट रिएक्शन, नाइट्रेशन, ब्रोमिनेशन हमने डिस्कस किया. And which of the following alcohols from appropriate to give alkenes here? That means we have completed. Will you see, for example, here this hydrogen if I shift up, you are going to get this one, and OH will be removed here. So we are going to get a Sedgwick product like this. Double bond here, CS. This is the product we are going to. Correct? Here we don't take. Why? Because if you take this one, what happens? We get like this actually. This is given homework in where alcohols only are given homework here. CH2, hydrogen. Here this will be the OH. This is the beta hydrogen, beta elimination reactions. Now this is also beta hydrogen. Now if you remember that last topic only, we can do this one. Now what happens? You are going to get this type of product. Double bond CH2. Okay. Now this is what less substituted. Sedgwick rule we have to follow. This will be the minor product, and this will be the according to what Sedgwick rule. Again, we can take what happened, beta hydrogen here or beta hydrogen here. But if you take this beta hydrogen, we are going to get Sedgwick product here. So we are going to get this product actually, and this will be removed here. We get actually what? Double bond over here. This way. Again, take this hydrogen and shift this one, we get OH here. We are going to get this is the bond. Similarly, what happened? You take here one hydrogen because tertiary hydrogen, this hydrogen you have to take here. You can't take here, you can't take here. Why? Because that is what will give less substitute. You can take and write the product actually. OH will be removed here. So we are going to get a double bond here, and like this. This is the structure where you try all these hydrogens, where we are getting what all which hydrogens? Beta hydrogens. Wherever we are getting double bond having what more substituted according to Sedgwick rule, isn't it? That will get actually. So when we have discussed this topic where in the properties of alcohol, conversion of alcohol into alkenes, Sedgwick rule, you just read that one, will get that. 33, how you do this one? 3-methyl butane 2-ol is treated with HBr. The following reaction takes place here. Give mechanism for this reaction. Now आपको क्या करना है यहाँ पर? HBr is treating this one with. Now they given the hint here. The secondary carbocation is formed in step 2, re-energized to more stable tertiary carbocation. So I'm doing one thing, something like this: CH3, CS3. I don't think this type of hard question they ask in examination, but anyhow, if we get doubts, we can discuss here. And HBr will release H plus here. H2O we get here because this HBr will give H plus to this one. The H plus is getting here. So we are getting OH2. Now this OH2 will be removed. So we are going to get this one: CH3, CH, CS3, CH, CS3, positive charge. So this is secondary, no? This one is secondary, no? So what I am doing here, I am taking one hydrogen here. This hydrogen I am taking here. Okay. Now if I shift this hydrogen with bond towards here, now it will shift into like this here. Yes, correct or not? Tell me better. Now this one will be the tertiary carbocation. Now which will be more stable? This is more stable, and this one will be the less stable. After this, the second nucleophile Br minus. This is the part Br minus. H plus is attack. Now Br minus will attack where here? Here. Now we are getting this product. So they are asking the mechanism for this. Okay. Now what happened actually? H plus added here. Okay. You got OH2 here. Now oxygen bond is shifted toward this bond is shifted to oxygen. You got a secondary carbocation. Secondary carbocation. Once the hydrogen shift here, what happens? You get tertiary carbocation. According to the theory part, tertiary is more stable. Therefore, what happens? You are going to get this product. So this is about the questions. Try to solve the problems here. So wherever you get Williamson synthesis reaction, Riemann-Tiemann reaction, Cole-based reactions, these are very, very important. All of you practice the Nemer reactions. Whatever the Nemer reactions we discussed in this chapter, practice all these reactions. Okay. So you have any doubts now? No doubts? Okay. Now, tomorrow I'll start that carbonyl compounds. So you complete this eaters exercise, Nemer reactions, whatever you're having, write down in the notebook. If you have doubts, ask me now. And are you coming today for taking record?